we're going to divide this polynomial, 4x to the third plus 8x squared plus 10x. We're going to divide that by 2x. So we're dividing a large polynomial by a monomial. So this one has 3 terms, this one has 1 term. So when you're dividing by a monomial, one of the best ways to do that, and the way that I prefer to do that, is to just make it into fractions and simplify those fractions. So what I would do is I would take, okay, 2x and make it the denominator of each of those. Because you're dividing that entire polynomial by 2x. It's like dividing each term by that 2x. And then simplify each of those terms. Not the only way to do this, is the way I prefer to do that. So if we go to simplify that first fraction, 4 and 2 have what in common? 2. So you would divide both of those by 2. And then there are 3 x's on top and 1 on the bottom. So how many cancel? 1 cancels. 1 from the bottom cancels 1 from the top. So that becomes 2x squared. 8 and 2, both divisible by 2. So we simplify that. Be 4. X squared over x simplifies to be just x. Because 2x is on the top, 1x on the bottom. 1 cancels 1, so it's just 1 left. So 4x. And then 10x over 2x, 10 divided by 2 would be 5. X over x does what? Cancels out completely. So
report to the office.
We've divided that polynomial by that monomial. We've got to be able to recognize that we're dividing by a monomial to be able to do that. Because it doesn't work if you're doing something different. Okay, so if you're dividing by a monomial, you can do that. Let's look at another one. 6x to the third plus 3x squared minus 12x. That's our polynomial divided by 3x. Are we dividing by a monomial? How do we know? It has how many terms? 1 term. That's how we know that we can do the fraction method of doing that. So that's what I'm going to do. I'm going to set it up. 6x to the third over 3x plus 3x squared over 3x minus 12x over 3x. And then simplify each fraction individually. 6 divided by 3 is 2. How many x's are left? 2, so it's x squared. 3 divided by 3 is 1. X squared over x. X, so it's just 1x, or x. Negative 12 divided by 3. So minus 4. X over x cancels, so that's our division. Not bad. If the fraction doesn't simplify all the way, like let's look at this example. 12y to the fourth minus 18y cubed plus 20 y squared, all divided by 4y. So again, are we dividing by a monomial? Yes, that's the question we got to answer so we know which way to do this. If we're dividing by something that only has 1 term, then we go ahead and set it up. 12y to the fourth over 4y minus 18y to the third over 4y plus 20y squared over 4y. And then simplify each fraction as much as we can. What does the first one become? 3y to the third, or y cubed. But the second fraction is 18 divisible by 4. No, but 18 and 4 are both divisible by what? 2. So divide them both by 2. So that'd be negative 9 over 2. And then how many y's? 2. You got y cubed over y is y squared. And then the last piece turns into what? 5y. Good job. If you're dividing by a monomial, that's a good way to do it. Okay, dividing by one term. That's my favorite way of doing that. It's quicker than what we're going to have to do if it's more than one term. Much quicker. So that's a benefit to that.
Is that 9 over 2?
9 over 2. So 3y cubed minus 9 over 2y squared plus 5y. All right, so let's look at how we're going to divide if we have something bigger that we're dividing by. So something that has more than one term that we're dividing by. So let's take a trinomial, x squared plus 2x minus 3, and divide it by x minus 1. This one, you can't just put them into a fraction because you're not going to get anything to cancel because you got an x minus 1. It's got 2 terms in it in the bottom. So you can't just put it into a fraction. What we're going to have to do is long division, like the old school long division where you have the little symbol here. You put what you're dividing by on the outside, what we're dividing into on the inside. And it looks like it's extremely difficult, but it's not. All it takes is knowing how to multiply to be able to do this. So when you're doing long division, the thing you look at is the front piece of what you're dividing by. You don't worry about the minus 1. That doesn't matter. It's going to affect things, but it's not going to, decide what happens. Okay. So what times x would give me this? X. X times x is x squared. So that's what goes up top. And I always kind of put it in columns, like I've got an x squared column, I've got a plain x column, and I got a number column there, right? So x times x would give me x squared. So I'm going to distribute x times x is x squared. X times negative 1 is negative 1x. And then I put that in parentheses. It's important that you remember that all of that is being subtracted. And I subtract. What's x squared minus x squared? What happens to them? They cancel out. That should happen every time. And then what's 2x minus negative 1x? Positive 3x. And then I'm going to bring down the next term. Okay. Now, again, I look at the front piece. What times x would get me 3x? 3. So that's what goes up top. It's a positive 3, right? Because that's a positive 3 right there. So it's plus 3 up here. And then I'm going to distribute again. Positive 3 times x. That's the 3x I wanted. Positive 3 times negative 1 is minus 3. And I'm subtracting all of that. Well, 3x minus 3x is canceling out. Negative 3 minus negative 3 cancels out as well. So the remainder is 0. So we did our long division, and x plus 3 is the answer that we got. Okay. You've probably never done, I know you've never done this before, y'all. This is not 8th grade math thing. This is a brand new thing. Okay. Simplifying the fraction thing like we were doing the first 3 examples, you've probably done something like it before. We've done something like it before in here. But this you never have done, I know. So this is a new thing. Let's divide x squared plus 3x minus 4. Let's divide it by x plus 1. So x plus 1 goes on the outside. X squared plus 3x minus 4 on the inside. It's important that you make sure they're in descending order, just like when we were factoring and all that stuff. Descending order is a big deal. If it's not in descending order, very difficult, not impossible to do, but much more difficult than it should be. Okay. What part of that do we look at? Only the x, the front part. What times x gets me x squared? X. Then what do I do with that red x that's up top? Distribute it. Oh, man. Been happening all day today. I don't know what the deal is. Reboot. And it kicked back off. Jeez. Okay, so we have this red x up here. What do I do with that? What did I do on the last problem? I multiply it to both of everything that's on the outside. So x times x is x squared. X times 1 is 1x. And then I'm going to subtract all of that from what's above it. Okay. X squared minus x squared cancels out. 3x minus 1x. 2x. Then I look at it and say, okay, what times this x here gets me what? 2x. What times x gets me 2x? 2. So I need a plus 2 up top. I'll use a different color. What do I do with that plus 2? Multiply times the x plus 1. So that's 2x plus 2. And I'm subtracting all of that from what's above it. 2x minus 2x cancels out, right? What's negative 4 minus 2? Negative 6. That right there is the remainder. And the way that we want to do a remainder with what we're doing here is we add the remainder over what we divided by. And that's your final answer. So divide. If there's anything left over, how do I know I'm done? Well, is there anything times x that'll get me negative 6? No, so that's how I know I'm done. I can't do that. I can't do something times x and get 6 or get negative 6. It has to have an x on it if I'm multiplying by x. That's how I know I'm done. So remainder on top, what we divided by on the bottom. It's kind of like a mixed number is what it turns into, but it's a mixed polynomial is the way you would describe that because it's got a fraction in it. Let's do another one. Let's say we had 2x squared plus 11x minus 9. And we're going to divide that by 2x minus 3. So we'll divide by something that doesn't just have a plain x on it. So it's a little bit more interesting. So set it up. 2x minus 3 on the outside. 2x squared plus 11x minus 9 on the inside. What times this, the 2x in the front, gets me the 2x squared? X. What do I do with that x? Multiply. X times 2x is 2x squared. X times negative 3, negative 3x. And subtract. I always put parentheses there and subtract. The parentheses are what keeps it, the subtraction of the whole thing. Okay. 2x squared minus 2x squared, they do what? They should do that every single time. 11x minus negative 3x. 14x. Then bring down the minus 9. What times 2x gets me 14x? 7. Do a plus 7. So that's 14x minus 21 that I'm subtracting. 14x's cancel out. What's negative 9 minus negative 21? positive 12. That's a remainder, so I'm going to go plus 12 over 2x minus 3. And that's the long division for that particular problem. All right, let's do a big one. Or a bigger one, I guess, would be the better way to put this. 5x to the 4th power plus 2x to the 3rd power minus 5x squared plus 10x plus 6. That's what we're dividing into. We're dividing by a trinomial, x squared plus 3x minus 2. This is as tough as they get, guys, for Algebra 1. Get a little tougher in Algebra 2, but not much. Process is still the same. What you're dividing by goes on the outside. Oops, minus 2, not plus 2. What you're dividing into goes on the inside. In descending order. Make sure you do that. This one was already in descending orders, but just don't screw it up. What times x squared will give me 5x to the 4th? I got 2 x's out here. I need how many more to make x to the 4th? I need 5 and an x squared to make that 5x to the 4th. So 5x squared goes up top. And I always put it over its like term is what it helps me stay organized. It kind of helps me know when I'm done too. If I organize it that way, once I get to the end, that's the end. That means I'm finished. Okay. Distribute the 5x squared to that whole trinomial. So that's 5x to the 4th. That's 15x cubed minus 10x squared. And I'm subtracting all of that. The x to the 4ths cancel. 2 minus 15 would be negative 13 x cubed plus 5x squared. Then I'm going to bring down the 10x. You're always going to bring down the next term. Then I look at it and say, okay, what times x squared gets me negative 13x to the 3rd? Well, be a negative 13 for the number part. How many x's do I need? I need one more, right? I got squared on the outside, so I need one more to make it cubed. And then distribute. And then positive 26x. So I'm just doing this to get this blue line right here. I'm just distributing negative 13x to this stuff. Subtract. Negative 13 minus negative 13 cancels out. That's what we want to happen. 5 minus negative 39 be 44, right? 10 minus 26 would be negative 16. And then I'm bringing down the plus 6. That's where that's coming from. Well, this one should be the easiest step. What times x squared gets 44x squared? 44. That's the easiest step. And then distribute. A little tougher to distribute here because you got a bigger number, but still, that's 44x squared. 44 times 3, 40 times 3 would be 120. And then 4 times 3 is 12, so it would be 132x. And then minus 88. Because 2 times 44 is 88. And I'm subtracting all of that. These cancel. And then I have negative 16 minus 132. So that's double, adding those two numbers be negative 148. 6 minus negative 88 would be 6 plus 88, which would be plus 94. I know this is the remainder because it's smaller than that. This is x squared, this is plain x. So this is smaller, so I know I'm done. There's nothing I can multiply x times and get a plain x out of it. X squared times anything is going to give me something with x squared at least. So I know that's a remainder. So the remainder, negative 148x plus 94 over what I divided by. That's the quotient or answer to our division problem out of that. All right, we will just do this section today. It's so hot in here. I'm afraid if I do another section, I'll get a little antsy. So we'll do 3 through 18 on page 788. That's a small set, 16 problems. If you're dividing by a monomial, I suggest doing that with the fraction style, like we did the first 3 examples. Anything else, it's got more than one term, do it with the long division, like we did the last 4 examples. Okay, so that's what you'll be working on when we come back from lunch, and get us some long division started. Get us into chapter 12. We'll probably go ahead and do the next section in chapter 12 tomorrow, and then you're out Wednesday, and then Thursday we'll come back and maybe do the next section in chapter 12 and try to get a little bit more real estate between us and the end of course test. ACT is Wednesday for freshmen and seniors do not come to school on Wednesday. Everyone else in the county comes.